Welcome to this explainer by Forge College. I am so incredibly excited you're here today. We are diving into assembling granular access components. Now, this is a major stepping stone within our applied Solidity development track, specifically in the access control patterns module. So we are taking your access control skills to the absolute next level today. We're going to build a production-ready, composable smart contract architecture that is so tightly secured, even your most chaotic rogue intern literally couldn't break it. Let's get right into it. Here is the master blueprint for our assembly line today. We'll be moving quickly through 6 key steps. First, from scripts to components. 2, the role manager blueprint. 3, granular enforcement points. 4, time-bounded delegation. 5, automated verification checks. And finally 6, packaging for integration. All right, section 1, from scripts to components. Let's take a really quick look at where we're coming from and why, exactly, we need this architectural upgrade in the first place. So you might remember in our previous lesson, documenting and automating script usage, we built some really functional ad hoc scripts. And hey, they got the job done. But right now, they're kind of just scattered pieces sitting on a messy workbench. You know, it's a bit like a toddler's Lego pile. To actually build advanced Web3 architectures, we have to take those pieces and evolve them into a tightly packaged, reusable, and totally composable component. Which brings us to section 2, the role manager blueprint. Because to prep for our capstone project, we really need to gather up those scattered Lego pieces and snap them securely together into one cohesive, centralized engine. Right at the very core of this new role manager engine sits this absolutely critical concept: has effective role. So instead of writing endless, messy spaghetti code to constantly check who has permission to do what, we use this single, unified check. It instantly verifies if an account holds a capability, whether they got it through a direct permanent grant or just a valid temporary delegation. It's brilliant in its simplicity. And surrounding that powerful core, we wire up these incredibly clear public APIs, things like grant role acts or delegate role. These let us securely manage access from the outside, granting, revoking, delegating, without ever exposing the complex, frankly, messy internal mechanics of our smart contract to the public. It keeps everything neat, tidy, and secure. Okay, moving right along to section 3, granular enforcement points. Now that we've got the role manager built and purring, we need to actually bolt it onto the chassis of our application, our managed asset. We do this by embedding what we call granular enforcement points. Basically, this just means placing logical gates using really strict and/or semantics directly inside our business logic. Think of them as highly specific security checkpoints wired right into the actual functions that move your valuable assets around. And these enforcement points, well, they generally come in 3 distinct flavors. First up, you've got your single role gate, like requiring a standard ROLE operator. Pretty simple. Second, a role pair gate. This uses and semantics, like you need signer A and signer B to approve something sensitive. It's your classic 2 keys to turn the submarine missile silo setup. And third, the role or time gate. This uses or semantics combined with time, which is totally perfect for emergencies where, say, an admin can act or someone with a temporary time-bound pass can step in to quickly patch a bug. Which leads us perfectly into section 4, time-bounded delegation. Since we're on the topic of time-limited access, let's explore what is arguably one of the most powerful gears in our entire new machine. Let's define delegation for a second. It is a securely scoped, revocable, and strictly time-limited granting of a role, given by an account that already holds it. Now, why is this so vital? Well, it cures the dreaded privilege creep. No more accidentally leaving some dev with full admin rights for 6 months after they finish their quick weekend task. That's a massive security liability just waiting to happen. To put it simply, think of those granular enforcement points we just talked about, those logic gates, as tough, unyielding VIP bouncers at the door checking IDs. Our delegation patterns, on the other hand, are the intelligent club managers who safely hire a bouncer for just a single temporary shift. Looking at it practically, this matrix outlines a recommended hierarchy. It clearly separates the managers from the bouncers. Your role admin is the ultimate boss, managing roles and revoking delegations. The role operator handles the routine day-to-day operations. And our signers handle those strict paired approvals. Everyone stays cleanly in their own lane, exactly as it should be. All right, section 5, automated verification checks. With our components fully assembled and that hierarchy beautifully set up, we absolutely have to test fire this engine before we even think about shipping it. We're going to use our automated non-interactive test scripts to execute this exact sequence. 1, deploy the component. 2, grant the role. 3, act on it. 4, revoke it. And 5, verify the revert. We aren't just guessing here, guys. We are mathematically proving that our gates lock and unlock exactly as designed every single time. So what do you think happens to a transaction if a user attempts an action exactly 1 single second after their time-bound delegation expires? Well, as part of our testing, we literally simulate time travel. We advance the blockchain's time just to check this. The result? An immediate, highly satisfying transaction revert. The bouncer kicks them out the absolute second their shift is over. No exceptions. And finally, Section 6, packaging for integration. The machine is working flawlessly. The tests are green across the board. So our final step is to box it up safely and ship it out. Now, a beautifully engineered component is totally useless if nobody else knows how to actually wire it up. And let's be real, developers kind of hate reading documentation. That's exactly why we include a crystal clear integration markdown file. It's essentially a quick user manual detailing the public API surface area, event semantics, some really easy copy-paste import snippets, and those crucial storage layout patterns. And here's a quick, modern pro tip for you. Vibe coding. You know you're going to be writing some repetitive boilerplate for granting and revoking roles, so let an AI handle the boring structural refactoring for you. But please always keep a human eye on those final security assertions. You definitely do not want to let a chatbot blindly sign off on the locks to your multi-million-dollar vault. And there we have it. Your component is now fully assembled, rigorously tested, and totally ready to be imported into any complex architecture out there. By learning to build these modules cleanly like this, you're tapping into the exact same structured engineering mindset we teach across all our advanced courses and community programs at Forge College. It's all about building with real intent and absolute clarity. So I'm going to leave you with one final question to ponder. Is your new granular access component completely sealed, tested, and ready to be wired into your next capstone project? Thank you so much for joining me for this explainer. Be sure to head over to forge.college to dive much deeper into this exact blueprint, check out the code for yourself, and explore other incredible Web3 subjects. Keep building smartly, and I will see you in the next one.